Hello once again, ladies and gentlemen. Root Beer here with the 2000 Pascal paper. We're on to question number 8. Hopefully you had a chance to take a look at it. So let's see what we can figure out. In the diagram, the value of y is, okay, short but sweet. That's fine. So let's take a look at our diagram. So we have a triangle here, and we know we have 60 degrees, 2 x degrees, y degrees, and x degrees up here. And the other thing I notice is that this y degrees up here is between this line and a line that's parallel to the base. Okay, so we want y, and we're given a whole other variable x as well. Okay, so what we're going to need to do is find y in terms of x or x in terms of y, things like that, and then hopefully we can solve this interior triangle, because we know the sum of these angles here is going to have to be 180 degrees. So we're going to have to use all the information available. So one thing I try and remember about parallel lines, because it does come up every now and again, is that if you have two parallel lines and they are both cut by the same line, that is this line right here, then these two angles, sometimes called the Z theorem, I believe. These two angles are actually going to be identical, so it's going to turn out that y is equal to x. Okay, but let's draw ourselves our little picture. So we have one line, and we'll say this is the parallel line. And okay. So we have y degrees in here, x degrees in here. I've actually extended this line here, actually a couple of the lines here, to really better illustrate. These lines here are parallel, and if they're cut by the same, I think it's called transversal because it goes across them, then it turns out that this angle in here is this angle in here. It's also this angle up here and this angle down here. It's basically the line cuts them both at the same angle. So it turns out this will be y degrees, and then y degrees and x degrees. If they're opposite, the intersection of two lines, opposite angles are equal here. Well, let's finish filling out the rest of our diagram. So we can see pretty quickly that x degrees is going to be equal to y degrees. Okay, the angle cut here is going to be y degrees here and y degrees up here. And opposite angles are equal when two lines intersect. Okay, so now, using the triangle, we know the sum of the interior angles is 180 degrees. So that's 60 degrees plus 2x degrees plus y degrees, but y is x degrees. So 60 degrees plus 3x degrees. So if we rearrange this equation, we get 3x degrees is 180 degrees minus 60 degrees. So that's 120 degrees. And if we just want x by itself, 120 degrees divided by 3 is going to be x degrees. So x degrees is equal to 40 degrees. But we were asked for y, not x. But y is equal to x, which we have just shown is equal to 40. And hey, wouldn't you know it, 40 was the answer to the last question too. That's pretty nifty. So there it is, E40. Okay, and if we wanted to, we could double check. Does this make sense? 40 degrees here, 80 degrees here. That's going to give us the proper angles for a triangle. It's going to sum up to 180. And 40 degrees here, 40 degrees here, yeah. Those two angles on the insides of the Z are equal. So 40 definitely makes sense, where as opposed to, say, 20 degrees does not exactly make sense. Okay. So we get our answer of E, and let's skip over to the next page for question number 9, but we'll have to wait for question number 9 in the next video. So I'll see all of you then.